This whisk contains an electric motor. An electric motor uses the motor effect, the interaction between fixed magnets and an electromagnet, to turn. It's one of very many examples of an electric motor being used. Here, the head of a rotary fan is just an electric motor. So how does this device work? Well, if you come over here, I've got a ginormous model to show you. Look at this, it's a ginormous model of a motor. And so we have a power supply here, and that's delivering a current that goes up this wire. It then gets into this rotating part of the structure. This is a coil of wire. And here, there are some electrical contacts and brushes that touch this thing, technically known as a split ring commutator. Now you see, if I put electricity through this, and this was it would just get hot. But it would create a magnetic field through this coil, like an electromagnet. If I then put some permanent magnets, represented by these two boxes, on the outside of that, then there's going to be an interaction. It's going to create an effect where at this point here, we would find that there is a south pole here attracting to this north pole, and then when it goes over the top, it now is repelled. The brush touches the other contact, it changes the direction of the field. And so this south pole now becomes a north pole and pushes away from this north pole. And then here, what happens is this north pole is now attracted to that south pole. And at that point, it changes on the commutator so that the current is running the other way, and it now becomes a south pole pushing away from that south pole and attracted to this north pole. Here, the current is reversed and it becomes a north pole pushing away from this north pole but attracted to that south pole. So you can see that every half rotation, the direction of the current changes, which changes the direction of the magnetism at each ends of this coil. And of course what that does is it provides a force acting at a certain distance, perpendicular to this coil, which creates a moment which rotates the whole structure. Now we can make a working, smaller version of this. Let's have a look. So the key ingredients here are that we need a permanent magnet on both sides, like this. And these create a magnetic field that goes across. What we're also going to do is we're going to wind a coil of wire around this rotating part here, and an axle that will hold it steady. And so what you can see here is you've basically made the first parts. The only thing we haven't included on this model yet are the actual wires. So you can see placing that in enables that to freely rotate within those two magnets. So here's one I made earlier. You can see I've coiled the wire around this moving part in the middle called the rotor. And when I turn the electricity on, the motor turns. And so this is a brilliant example of how we can make the motor effect, the interaction between an electromagnet and an ordinary magnet, create a rotating motion that we use in all sorts of appliances. A really good question is, well, how do I make my motor more powerful? How do I make it turn faster? Well, you could do a number of things. You could have stronger permanent magnets around the outside. You could have more turns on that coil of wire. And you could also put a larger current through it. Now, because the first two you would have to physically change the motor for, most appliances have a variable current. By controlling the amount of resistance in the circuit and the amount of current flowing through the motor, we can actually affect different rotation speeds. And that's why you get the different speeds on a whisk.